Welcome to Stresses Square, where learning is relaxed. Let's go find them all. Why does a moving object not keep moving forever? Newton's first law says that an object in motion should remain in motion unless acted upon by an external force. We know that in reality, objects slow down and stop. The reason is friction. Any object moving on a surface experiences forces exerted by the surface. The normal force and the frictional force. Normal force acts perpendicular to the surface, balancing the force exerted by the object. However, frictional force or friction acts parallel to the surface, opposing the object's motion. Friction comes in many types. Based on the state of motion, we have static friction, which prevents movement, and kinetic friction, which acts when objects are already moving. Based on the mode of contact, there's sliding friction, which occurs when surfaces rub against each other, and rolling friction, which involves wheels or spheres. Depending on the medium, friction can be dry, air, or fluid friction, where air resistance and water drag play a role. And finally, special types like skin friction in aerodynamics, pipe friction in fluid flow, and even quantum friction at atomic levels also exist. In this discussion, we will focus only on dry friction, also known as Coulombic friction. This type of friction occurs between two solid surfaces in contact without any lubrication and acts parallel to the surface, opposing the motion. Dry friction happens due to two main reasons. First, tiny surface bumps called asperities that lock together. Second, atomic forces pulling between surfaces. That's what creates resistance to motion. If we plot friction against the applied force, we can observe two distinct regions: static friction and kinetic friction. In static friction region, as you gradually apply force to an object at rest, static friction increases linearly with the applied force. This continues until it reaches a maximum value known as the limiting friction. At this point, the object is on the verge of motion. At the point of limiting friction, the static friction force is equal to the coefficient of static friction multiplied by the normal reaction force. In this case, net force is equal to zero because the object is still at rest. In kinetic friction region, as the applied force exceeds the limiting friction, the object starts moving. Unlike static friction, kinetic friction remains almost constant, regardless of further increases in the applied force. In the kinetic friction region, the net force is equal to applied force minus kinetic friction opposing the motion. Now, let's talk about the coefficient of friction, denoted by mu. It measures how much frictional resistance exists between two surfaces. Before the object moves, the maximum static friction is equal to mu s multiplied by the normal force. Here, mu is coefficient of static friction. Once the object starts moving, friction slightly reduces and becomes F equals mu k multiplied by normal force. And mu k is coefficient of kinetic friction. Mu k is always less than mu s, which is why it's harder to start motion than to keep it going. Now, let's take a look at the laws of friction. Friction always resists the relative motion or tendency of motion between two surfaces. When you push a book, friction pushes in the opposite direction. The frictional force is directly proportional to the normal force N, which is the force pressing the surfaces together. A heavier box is harder to slide because more normal force means more friction. The total friction force does not depend on the surface area of contact, as long as the normal force and material remain the same. A wide disc and a narrow disc of the same weight experience the same friction when slid across a table. The amount of friction depends on the types of materials in contact. represented by the coefficient of friction. Imagine kicking a football on grass and then on a smooth tiled floor. On grass, the ball slows down quickly because of high friction. But on a smooth floor, it keeps rolling much farther due to lower friction. The force required to start motion, that is, static friction, is always higher than the force required to keep an object moving, that is, kinetic friction. It takes more effort to start pushing a heavy box than to keep it sliding. Thanks for watching. See you in the next video.